Hi, this is Mr. Anderson, and in this video we are looking at orbital movement and terms. As you're going through your space science unit, there are lots of orbital terms that come up, and if you don't know what they mean, it can be kind of confusing, and at least you're missing the real message of what's happening. So, in our image here, we have a picture, and we're going to use this picture in a moment, and you can see on the right side there's lots of terms. On the left side, there are lots of definitions that go with them. So we're going to put all these in place and figure out how all this works. To start, we have the sun in our image, and this pink purplish line that's circling the sun is the orbit of Venus, and this blue outer line represents the orbit of the Earth. Now, let's start with the Earth. I first want to point out that the Earth has this red line going through it. And this red line represents the fact that Earth is not a perfect 90 degrees. It's actually tilted 23.5 degrees off of 90. Right, so this is Earth's tilt. And that's very important because when you're on the side of Earth pointed towards or leaning towards the sun, that's when you have summer. And when you're on the side of the Earth, it's tilted away from the sun. That's when you have winter, right? So let's talk about this blue line here. So first of all, this blue line is called an ellipse. It's very close to a circle, but it's not a perfect circle. It's kind of this oval shape, and we call this oval shape an ellipse, right? And you already may know this, but this blue line we would call the orbit. So let's take our first two terms here and match them up. So let's find the one for the ellipse. There we go. Let's go ahead and match this up here with the ellipse. Okay, and the ellipse is an oval-shaped orbital path. And orbit is the path an object takes around another solar body. So in this case, the Earth is orbiting the sun, and Venus is orbiting the sun. Okay, so we know that objects like Earth orbiting the sun or the moon orbiting the Earth have a length of time to do that. And the amount of time it takes the Earth to go around the sun or Venus to go around the sun is called revolution. So let's stick this over here, and I'm actually going to stick revolution up here. Oh, and that works out well because the revolution is one complete orbital trip. Okay, so let me get those two connected. All right, so one complete orbital trip is a revolution. Let me move that over here a little bit. I think I'll like that better. Okay, and as the Earth is traveling around its orbit, it's also spinning. And it's important to note here that as it's spinning, there are two ways it could spin. So it's believed that when the solar disk developed in our solar system, that it was spinning counterclockwise. Okay? And so counterclockwise would be represented by this orange arrow. Let's go ahead and move this orange arrow over here by the sun. So the sun rotates counterclockwise, and we call this type of motion prograde. So prograde is the norm in our solar system. The sun rotates prograde, the Earth rotates prograde, and almost all the other planets do. So let's label that. Bring our label over here. So spinning the same direction as the sun, which is counterclockwise, is prograde. Okay, so the Earth rotates prograde. Let's go ahead and copy this arrow and move it over here to the Earth to show the Earth rotates prograde also. Okay? And one complete spin around the axis is the period. Okay? So let's move the time to rotate once over here with period. And we've also talked about rotation. Rotation is the spin of a body on its axis. We can move this over here with rotation. Okay? And the other type of rotation, there are a couple objects in the solar system that don't rotate the same direction as the sun. And that's called retrograde. And in fact, Venus is one of these objects that does retrograde rotation. That's spinning the opposite direction as the sun. So it actually spins clockwise. So if you've ever looked at an analog clock, it's moving in the same direction. Okay? The other solar body in our solar system that does this is Uranus. So all other planets besides Venus and Uranus orbit in a prograde fashion. Right? So they spin counterclockwise. The last two terms to talk about are aphelion and perihelion. And these two terms refer to the distance the Earth is from the Sun and its orbit. So because this is an ellipse, that means that there are some times where the Earth is a little closer to the Sun and times when it's a little further away. I want to point out this is not what causes seasons. It's the tilt of the Earth and whether it's facing towards or away from the Sun and its tilt that causes the seasons. And the way I remember this is A for away. And in my shape here, aphelion, we could actually leave aphelion over here. Let me move these around. So the sun and the earth are going to be closer to aphelion right here in my picture. And aphelion is when the earth is further away from the sun in its orbit. So A for away. See if I can fit this all on here. Let me move these around. All right, and the opposite of aphelion is perihelion, and that's where the Earth is slightly closer to the Sun in its orbit. And for us, this actually happens in winter. So in the wintertime, usually January, is when the Earth is slightly closer to the Sun for us in the Northern Hemisphere. And in our summer is when we're actually furthest away from the sun. Now, it's opposite for the people in the southern hemisphere because they're tilted the opposite direction we are. So it all depends on your tilt for your season. Okay, so these are a lot of terms. Take a look at these, go over them again, make sure they make sense to you so that as you're studying your space unit, you'll be familiar with the terms people are using. Good luck. Till next time.